Okay, tonight we're going to actually begin to explore the concept of division in the context of relating it to multiplication. So, what I would like for you all to do is, I would like for you all to take a few minutes to copy the link down and to access this video and seeing how division can actually be understood or misunderstood as it relates to procedures. Hopefully you've had time to pause the video to actually view the video hyperlink. So our objective is to explore the different interpretations of division and understanding the relationship between multiplication and division. We're going to also begin to explore some strategies for supporting students' understanding of division beyond the traditional or the procedural method. So first of all, what does it mean to divide? I want you all to take some time and look at class activity 6A. I would like for you to pause the video and work through questions numbers 1 through 3 for class activity 6A. Okay? So as you work through class activity 6A, you were asked to come up with a story problem that would fit a few different equations. So I'm going to present two examples that should be similar to what you found. So the first problem I came up with, or story problem, is Marcia has 10 cookies to equally share with her two friends. If Marcia doesn't eat any of the cookies, how many cookies will each friend receive? So I know that Marcia has two friends. I'm trying to find out how much would each friend receive. So if I am to share the 10 cookies, each friend would get 1, 2, 3, 4, and 5. So I'll see that each friend, which is represented by the red circle, would get a total of 5 cookies. This is the most popular format for division in a lot of our classrooms. Students look at how to actually partition or share an amount amongst a known number of groups. So in this case, I had 10 divided by 2. I was trying to find some unknown quotient. Now, in relating this back to multiplication, I started off knowing that I had two groups of some unknown amount, and I knew that it had to total 10. So in this case, 2, I knew my number of groups, but I did not know how much was in each group. So this is looked at as the partitive or the partitioning interpretation of division, which looks at how many, or which seeks to find how many is in each group. Okay? Then you were asked to write another simple division word problem that fit with the other expression, which in this case, the expression that marks a question mark times 2 equals 10. Well, the story problem that I came up with is Marcia has 10 cookies. She wants to give away to her friends. If she wants to give each of her friends 2 cookies each, how many friends can she share her cookies with? So in this case, she knows that each friend, which is represented by the red circle, will get 2 cookies. She doesn't know how many friends she'll be able to share with, but she knows the amount that each friend would get. So in this case, she'll keep measuring out groups of 2, 2, 4. There are 6 of my cookies, and she'll keep doing this until she doesn't have any cookies left over. This is called measurement because you're actually physically measuring out a known amount until you have no more left over. So in this case, I was trying to find how many friends, so how many groups I did not know, which is the reason why the red question mark is there. How many groups of 2 would be a total of 10 cookies? So in this case, I would be able to share with 5 friends. So we have 2 very different contexts. Although the same equation is used for each of the story problems, 10 divided by 2 equals 5, they're very different problems, and in each problem, the 5 represents something very different, and the 2 represents something very different. So let's take a look at it. So in the first problem, The 2 represented the number of friends that I was going to share the 10 cookies with. And I didn't know, which is the question mark, how many cookies each friend would get. So I was trying to find how many cookies. So in that case, the 5 represented the amount that each friend would receive. Now in the second problem, I don't know how many friends, but I know that I want to give each friend 2 cookies for a total of 10 cookies. So in this case, my 2 represents how many cookies each friend would get. And my red question mark, or what I'm trying to find, is how many friends would I be able to feed with those cookies. So in this case, 5 represents the number of friends. So if I was just focused only on procedures, I could work through this 10 divided by 2 equals 5, and I would get 5 for both, but 5 represents something very different depending on the word problem. And a lot of times, our students, when they have word problems, they are not able to correctly solve them because a lot of times their equation does not match the actual word problem context. So I want you all to compare these two and to see how the answer that I found of 5 is very different depending on the context, and that's only evident by looking at the 2 equations that I'm actually trying to solve as it relates to the multiplication equations. So I have a quick definition here for you all to take a look at. The number of objects that are in each group when A objects are divided equally among B groups. So that means I know the number of groups, which is B times some unknown. I don't know the amount in each group. So that would fit a context where I'm trying to find how much would each group receive. The second format is the number of groups that are formed when A objects are divided into equal groups of B. So in this case, I don't know how many groups, but I know the equal amount that will go in each group. So notice, the multiplication equation that relates back to the problem is very different depending on the context of the problem. I want you all to make sure that you are able to distinguish the difference between the division and the multiplication equation that actually aligns with each problem context. Now I want you all to take a look at class activity 6B. Pause. Hopefully you've had some time to take a look at class activity 6B. And I want you all to explain. Okay, let's take a look at, can we divide by 0? And I want you all to really think about that. Can we divide by 0? If so, why? If not, why not? And I want you to explore class activity 6C in doing so. If you could pause the video and then replay it after you've worked through class activity 6C. Okay, so hopefully you've worked through class activity 6C, and what it has allowed you to see is it's very important that students understand the relationship between division and multiplication and being able to actually prove whether we can or cannot divide by 0. So in this case, I have 2 divided by 0 equals some unknown. So I have an amount that I'm dividing amongst either 0 groups to find out how much each group will get, or I have 2 that I'm actually dividing or measuring out groups of 0 to figure out how many groups I'll have. So if I had to rewrite those equations, I could say some number of groups of 0 equals 2. Well, how many groups of 0 would ever equal 2? It's impossible. Or I could say 0 groups of some amount would equal 2. 0 groups of no amount will ever equal 2. So in this case, it is undefined to divide by 0, and we could use the relationship between multiplication and division to come to those conclusions. So how do we support students' understanding of the division algorithm? I want to take a look at a couple strategies in developing the understanding, starting with mental math. For the equation 110 divided by 8 equals some unknown, I could mentally say, well, how many groups, because I know the relationship between 110 divided by 8 equals some unknown, I could say Oh, I want to measure out groups of 8. So how many groups of 8 will equal 110? Okay, so there's 1, 2, 3, 4, 5 groups of 8. That gives me 40. I can do another 5 groups of 8, which would give me 80. So I'm trying to get closer to 110. So 10 groups of 8 is 80. I can add another group of 8 for 88, and I can keep adding groups of 8 until I get as close to 110 as possible. So I got to 104. If I added another group of 8, that would take me over. So let me say 105, 106, 107, 108, 109, 110. So 10 groups of 8 plus 3 more groups of 8 plus 6 will give me 110. If I was to use my distributive property, I know that that would be 13 groups of 8 plus 6 equals 110. And students can use this as a strategy for division. Their answer will be 13 with a remainder of 6. Or they may say 13 groups of 8 and a part of another group of 8. 6 out of 8 more, which is a fraction of 3/4. So it could be 13 and 3/4. I want you all to pause the video and take a look at class activity 6F and exploring how mental math can be used to support students' understanding of division. Okay, hopefully you've had some time to work through class activity 6F. The second strategy that the text talks about is scaffolding. Well, of course, measuring out groups of 8 is easy when you have smaller numbers. But what about when I have a number such as 978? To physically measure out groups of 8 ones from 978 would take a tremendous amount of time student-wise. So what I want to do is I want to scaffold out in groups of 8. So this is how I would scaffold out in groups of 8. I would say, well, how many groups of 800s? Well, I know there's not going to be any thousands because my number is less than 1,000. So I'm going to start with hundreds. How many groups of 800s is in 978? Well, one group of 800. I know that 2 groups of 800 would be too much. So one group of 800s is the same as 1 times 8 times 100. I use my commutative property, and there's 100 groups of 8 in 978, which is a total of 800. I have 178 left over. Now that I've found the number of hundreds in 978, now I can find out, well, how many groups of 8 tens are in 178. So in this case, I go 8 tens, that's 80. 8 more tens, that's 160. If I keep going, that would be beyond 178. So in this case, it's 160. So I have 2 groups of 8 tens, which is the same as 2 times 8 times 10. Use my commutative property. It's a total of 20 groups of 8 for a total of 160. I'm left with 18. Now my question is, how many groups of 8 ones? So 8, 16. So there's 2 groups of 8 ones for 16 with 2 left over. So notice, instead of me having to continue to measure out 8 ones, I'm able to measure out groups of 800s, groups of 8 tens, groups of 8 ones, because within each of those place values, you can actually break the numbers down, use the commutative property, and then find out the number of groups of 8s. I want you all to now work class activity 6G and gaining and practicing the scaffolding strategy. Hopefully you've paused the video and you've had time to work through class activity 6G. Now I want you all to pause the video and work through class activity 6H. Hopefully you've had some time to work through class activity 6H. Now I want to introduce you all to another strategy for division, the area model. And prior to us looking at division, we looked at area models of area arrays in multiplication. This strategy is applied as such. 513 divided by 4. Well, I know that my number of groups goes along my vertical area. So there's my 4 groups. I know that the amount in each group goes along the horizontal. So 513 is broken up by place value. 500s, 1 group of 10, 3 ones. So what I'm going to do is I'm going to actually distribute the number of hundreds, the 500s, with amongst the 4 groups equally. So I can share or partition 100 there, 100 there, 100 there, 100 there, and then I'm left with 100. I can only equally share 100 with the 4 groups. So I'm going to take my leftover 100 and I'm going to rewrite that as 10 tens, which would now give me a total of 11 tens. Now I want to equally share those 11 tens with the 4 groups. So the first group will get 2 tens, 4, 6, 8 tens. I don't have enough tens to share more, so I'm left with 3 tens. Those 3 tens can be rewritten as 31s, or for a total of 33 ones now. And if I was to equally share the 33 ones with the 4 groups, each group would get 8 ones with 1 left over. So my answer would be, how much would each group get? So if I was rewriting 513 divided by 4, I know there's 4 groups, so I'm trying to find the amount in each group. So if I looked at the amount in each group gets 100, 2 tens, 8 ones. So that means that 513 divided equally amongst 4 groups, each group would get 128 with 1 left over. I want to now practice this strategy, and complete class activity 6I through J. Hopefully you've had time to work through each of the class activities. If you have any questions or concerns, please feel free to give me a call, text, or email. Please do not forget to upload your completed class activities under the online lesson number 4 in ELC. We've taken a look at section 6.1, 6.2, and 6.3. I want you all to at least try to work through some of the practice problems. You don't have to submit it. That's just for additional practice. But you are to submit the homework that involves the problem sets for 6.1. Please see your syllabus. You do not have to do any problems for 6.2, only 6.1 as the syllabus states. Have a great evening.